Okay, so this morning we want to look at a feature which makes computers very powerful, and that's the case of functions. So we introduce you to something called functions, and basically, first of all, these are objectives we want to see. We'll have a look at what a function is. Then there are different types of functions which Python comes with. There are these functions which Python comes with out of the box. These are what are referred to as built-in functions. There are 70 of these functions. So out of the box, you've got access to 70 functions you can use straight away. We'll see how to give these functions information. Some of them we've already looked at. So those we have looked at, we will not repeat them because we have got recordings of all these lectures where you can go back. We'll see how to pass functions to these built-in functions. We'll also see how to store a value which has been retained by these same built-in functions. Apart from these out-of-the-box functions, Python gives you the ability to create your own functions because 70 functions might not be enough. There are also other types of functions called methods, which you have seen before. These are associated with specific data structures. So that particular bit we are not going to look at. We're just going to look at the built-in functions and also how you create your own functions so that you can accomplish whatever physics or mathematics problems you have. So basically we'll look at two types of functions you can create yourself. These are what you call user-defined functions and small, tiny functions which you can use for mathematics called Lambda functions. So after we create these, we'll see how we can use these. And when you're using a function, that's basically called a function call. And we'll see how we can give them information. That's called passing information, passing arguments. And later on, we'll see how we can save the information which has been stored from these particular functions. Okay? Now, what is a function? Now, a function is basically a piece of reusable computer code. So you put together some lines of computer code and you package them in such a way that you can use these lines of computer code repeatedly for solving a particular task. Now, a good function naturally will perform only one task. So if you've got a function which tries to perform one or two things, then that's by definition not a good task because a good computer function needs to perform only one task and it needs to try to do that very, very well. So when you're writing a function, you should have in mind what kind of task you are trying to accomplish. If you end up writing something which ends up doing too many things, then that's a sign that your function is too big. You need to break it up into smaller pieces which are going to accomplish only specific things. So as we have said, out of the box, Python comes with functions. The functions which Python comes with out of the box, these are what are referred to as built-in functions. You don't need to do anything about these particular built-in functions. The only thing you need to do is you need to know the name of the function and what it does, so you end up calling this particular function. There are also other functions which Python comes with out of the box called methods. Now, methods are associated with specific data structures. For example, we have looked at lists, we looked at dictionaries. So when you talk about a method for lists, these methods or these functions only work with lists. Okay? They only attend to lists. The other ones only attend to strings. The other ones, these functions only work on these particular data structures. So if you have got a data structure and there are these functions which only work with that particular data structure, those functions are called methods. So there is two classes of functions. There is the actual function itself, which works with everything. There is a method, which is a specialized function which works with only specific things, data structures. How do you know what a method is? Basically, when someone is using a method, they have to put a dot somewhere. So they will say the name of the structure, then they put a dot, then the name of the function afterwards. Like I've said also, you are allowed, Python comes with the ability for you to create your own functions. We are doing different things, we are in different fields of physics. So basically, probably in those different fields of physics, you probably need to accomplish different tasks. So you can actually sit down and create your own function which does those particular tasks so that you can work much faster. So look at two types. There's something called user-defined functions. Basically, these are much longer, and their abbreviation is UDF. And there's something called a Lambda function. These are basically one-line functions which do a specific things. So when it comes to built-in functions, right now with Python, you have got access to 70 built-in functions, and basically this is the list of those particular functions arranged in terms of alphabetically. So under A, you have got a function called apps, which you're going to look at. Then there's some others which we'll not look at today. Then there's B. Then under C, there's all these functions here. In this particular lecture, we're going to look at a function called complex. Under D, they've got all these other functions here. Some of them we've looked at. Under E here, we'll look at enumerate, we'll look at evaluate, we'll look at execute. Then there is under F, there is all these functions here. Under G, there is that. Under H, there is also a bunch of functions there. Then under I, there is all these functions which are here. Some of them we've looked at, for example, int and input. Then here under L, there is length function. We have seen that what that does. It gives you the size of a data structure. Then there's a list function here. Then we'll look at this one. Then under M here, there is all these other functions here, but we'll look at max and min. And under N, there is next function. And under O, there is all these other functions here. Then under P, we'll look at this one here, the power function. This is a print function. We have already seen what the print function does. Some of these functions have already met before during the course of these lectures. Then there's under R here, there's a range function. We'll look at that. And there's a round function here. Then under S, there's set. You have seen set function before. We used it to create data structures called sets. Then there's also something called sorted here, which we're going to look at. And basically, there's some here, also here. Then also under T here, with a function called tuple. Now this particular function called tuple, we'll see what it does today. But basically, you can, if you've got a list, you can use this particular function to convert that list into a tuple, so that we don't have to create anything from scratch and like that. So basically, these are 70 functions you can use for specific tasks out of the box. When you just open your Python environment, you can start using these functions as long as you know their name without much of trouble. You don't have to do a lot of things. So for you to use any of these functions, that's what's called calling a function. When you're using a function, that process you're going about using a function, that's what calling a function. For you to call a function, you need to know the name of the function. So you start out by typing the name of the function, then followed by a pair of parentheses. Then in this parentheses, if this particular function needs additional information to work, for example, we had a function called minimum somewhere here under M, under M there. So minimum, basically, you have to give it a bunch of numbers. Then this particular function will figure out of this bunch of numbers you've given it, which one is the smallest. Okay? So there are certain functions which need additional information to work, and you have to provide that additional information. The additional information you are providing a function so that it can work, that is what is called an argument. So basically, this is the terminology which is there. So when you're using a function, we say you're calling a function. The information you provide the function so that it can work properly, those are what are called arguments. So you can provide one argument, maybe that's all the function needs, or you can provide multiple arguments. It depends on what the function is actually trying to do. And basically, this is the general recipe for using a function. Basically, here you start out with the name of the function, then the parentheses, then inside the parentheses, that's where you're going to put your arguments there. Okay, so the arguments can be one argument, one piece of information you're providing, or it can be multiple pieces of information. So the first function which we are going to start with, of course, is something called help. Now, as the name of the function suggests, this particular function is designed to give you more information about a particular function. Okay, so how do we use this particular function? Well, you start out with the name of the function, which is help. Then remember we used the length function, right? Where we used it to find the size of how many items are in a list or in a tuple, or how long a string is. So if you give this particular function help this particular argument, which is the name of a function, then what is it going to do? If you do that, it's going to give you the name of the function and how the function is supposed to be used. Then it will give you a short description of what that particular function does. So basically here it says returns the number of items in a container. So these containers we have seen can be lists, can be... Yes.
So you have that help function, right?
Mm-hmm.
And then in the brackets there you provide an argument.
Yes.
Which is laying there.
Yes.
So the argument also is function, right?
The name of a function, yes.
Okay, so function of function.
No.
That?
The argument there is basically the name of a function. I want to find out what does this particular function do before I use it. I know what the name of the function is, but what does it do? So inside here, the argument is just the name of the function.
Okay.
So basically, this is how you use the help function.
Is it different when we are on the internet, on the computer, search for help, then a word that you don't understand, maybe then it gives you some information? Is it the same as here?
I'm not sure, because here this whole help thing, as we are going to see when we make our own functions, you provide a bit of a description as you are making a function of what the function is supposed to do, so that other people who are using that particular function can know what they're supposed to use that particular function for. So in this particular case here, I chose this particular function length because we had used this function earlier and we saw what it does. It basically counts how many items are in a list, in a string, or basically like that. It counts that, then it gives you the number. So basically, that's basically what you get here. You just get a description of what that particular function does. How it does it, it doesn't show you. It just tells you this guy does this. But how it does it, it doesn't show you. Okay. So basically, that's our first function in this particular case. Then another function is this one, built-in function, Boolean. When we started out, in our first lecture, we met this particular function. And we said, when we used it, we said that if you give the Boolean function a 0 value, it's going to change this 0 value into a true. Into a false value here. And if you give it a non-zero value, for example 1, then it's going to change that non-zero value into a true value. Then, since then, we have learned other kind of data structures. For example, we had learned about lists, we had learned about tuples, we had learned about strings. Now, if you get an empty string, like in this particular case, a string which does not contain any characters, you give it to the bool function, it gives you a false value. Basically, this is a way of telling you to say this particular string does not contain anything. Okay.
So that one automatically is 0, right?
Yes. So if a container does not have anything, it's evaluated to be a 0. If it contains something, then it's evaluated to be a 1. If we give it a string which contains characters, for example here, hello, and we evaluate this one, it evaluates to true. So this is a clever way of you checking whether a container contains something or not, without you actually having to print it. Okay. The same thing, you can do the same thing with a list. If you give it an empty list like that, only 2 square brackets without anything, this one evaluates to false. There. Then if you give it a list which contains some items, we've got 3 items here, apples, oranges, and guavas, it evaluates to that. To true. So basically, that's some additional stuff which you can do with that particular function. We have made that before, but I wanted to bring out that bit in light of the new information which we have come across. Okay. There's another function called tuple. Now we know that a tuple is a container or a data structure whose items you cannot change or you cannot modify. Once you have created this container, the items, this particular container, you cannot modify that. So usually if you have a list of items you're happy with. For example, in this particular case, I've got a list of fruits, apples, oranges, and guavas, and I'm convinced that this is a list I'm happy with. So I save this particular list in the variable fruits. Then I print out this list. Okay? And I don't want to change this anymore. I want it to stay the way it is. Then I will give this particular list to a function called tuple. Now what this function tuple is going to do is it's going to copy whatever is in this particular variable, fruits, which is this particular one. Then it will change it into a tuple and save it back into fruits, like that. So with this one line, you get your list, convert it into a tuple and save it back into that particular variable. And now when you make a printout, what you see is that now you have got a tuple instead of a list. As you can see, a list has got square brackets, starts with an end with square brackets, but a tuple starts and ends with parentheses like that. This particular structure, as we have seen before, has the property that you can't modify anything which is there now. Okay? There is also a function called list. Now, for this particular function called list, if you want to make changes to your tuple, you have got a tuple. Now you're feeling like you want to add something or remove something from there. So you can change that particular tuple into a list using the function called list. So in this particular case, this is our tuple. Then I want to change this particular tuple into a list. So I'll give the variable fruits as an argument to the function list. Then this particular function will make a copy of this particular tuple. Then it will change it into a list. Then save it back into this particular variable fruits. This here is an assignment operator. Basically, it says whatever is on this particular side, store it this on the left-hand side, like that. So if you make a printout here of fruits, now you see that fruits is now holding a list. So basically, that's how you move quickly without you having to build a list or a tuple from scratch. If you already have one, then you want to have another version of that particular thing, you can basically use those two functions, tuple or a list, the list function or the tuple function. And the names of these particular things are quite suggestive about what these things actually do. Then here you've got a function called max. So basically, if you've got a list of numbers, for example here, I've got this particular list of 50, 25, 100, and 80. Then I give this particular list the max function. What the max function is going to do is going to give me back which item in that particular list is the largest, and basically that's 100. And I can also give max. So here I've given it a data structure, but I can also give out these particular arguments like this, so that they're separated by commas. I can give out multiple arguments.
Is there a limit as to the number of arguments?
No, there's no limit.
So
you can put as many. Yes, you can put as many as you want. Yeah, like that. If you do it like that, it still gives you your 100. So this one works whether you put in a container which contains information like this, or you simply put in your items, arguments individually like that. The opposite of that is the minimum, which is min function. With the min function, if you put that particular list there, then you get 25, and if you do the same thing here, you get your 25, which is the smallest item in that particular list of values. Then there's a function called complex. This particular function called complex basically creates a complex number for you. So if you need to work with complex numbers, remember when we started, we created a complex number on ourselves, but there's actually a function you can use that. So basically the only thing you need to do is, for example, if you want to create this complex number 5 plus 4j, the only thing you need to do is you need to give it arguments. The first one will be the real part, then the second one is going to be the imaginary part. So if you do this, say complex 5, 4, then this guy is going to manufacture a complex number for you, which is 5 plus 4j. If you want to only create the imaginary part, it means that the real part has to be set to 0. So if you say complex 0, 4, so in this particular case, you're only going to end up with 4j. If you simply want 5 plus 0, 4j, it's sufficient to just provide one argument, complex 5, then it's going to create for you 5 plus 0, 4, like that. So basically, This is a fast way of you creating complex numbers. If you are working with complex numbers, then you can do that.
Question is on line 20 or something. Is it possible to say complex and then just comma 4?
Complex, just comma 4.
Without the 0.
Okay, let me see.
Can you check it?
Okay, I can check, yes. Complex. Comma 4. No, it fails. Yes, it's not possible.
What about complex 0, comma, minus 4?
Yeah, this one works.
That will work.
That will work. That will work.
That should give you a negative j.
Where is it? Huh? Oh, I deleted. Okay, let me add. Complex 0 minus 4. Yeah, there. Minus 4j. Okay. So basically, those of us working with the complex space, here are the tools for you to use. Once you create a complex number like this, you can actually save that complex number you've created in a variable like this. So this bit here on the right hand side, it creates complex number. Then you can save it in the variable z like that. Okay, then you can print out the z. Then you get a complex number. The other thing you can do, of course, is you ABS. Yes.
Just stay on complex. Can you have like two complex numbers in that complex function?
What?
For example, like two of them. Like that.
No, this one only creates, you give it two, the real part and the imaginary part, then it creates one complex number for you.
Okay.
So if you want to create another set of complex numbers, then you have to call it again, then it will create them for you. Okay. There's another function which is of interest to us as physics people, which is ABS, which is absolute value. And of course, we know that if for absolute value, if you give it a positive non-zero number, of course, it looks like it doesn't do anything. If you give it 5, you get 5. But if you give it minus 5, you get 5, a positive 5. So basically, this is the absolute value operation. But we also know that you can work out the absolute value for a complex number, which is the size of the complex number. And in this particular case, you can say absolute value, you give it a complex number z, and when you do that, it quickly works out for you what the magnitude of that complex number is. Okay.
So then if you only need it to one decimal place, you can still set that, right?
We'll see how to get to the... So that will be another... So the thing of setting only to one decimal place, that is another function which does that. And you're going to see it. It's in this... It's among the list of functions I chose to show today. A function called round. Basically, it rounds off a number to a particular number of decimal places. Okay. There is also... sometimes you have to do summations. So there's a function called sum. In this particular case here, sum. Now this function called sum, if let's say we give it a list of values like this, and we create a list like that, then we print out this list of values, then we give this particular function sum a list of these values like that, then it's going to work out what the sum is. It's going to add up everything and give you what the sum is. This is very useful because sometimes you need to work out what the average is. So if you want to work out what the average of those particular things, then first of all you start out with the sum operation, then you divide by how many items you have in that particular list. So the top part here will do the summation, which is going to give you this bit here. The other bit here, this is the length function. It's going to count how many items in that particular list. Then you're going to carry out that division like that. Then you can save the calculation in average, the result of this calculation in average. Then if you print out the average like that, you get what the average is. So that's a quick way of doing your average business. Okay. There is another one which you might be interested in.
Sorry, Mr. Sichone, just go back to the numbers a bit. I'm interested in significant figures.
It will work out what the required significant figures is. Here is
It appears it gives the correct answer without concentrating on the significant figures. You see the least number of significant figures there are 1.
Yeah.
50 and 80 have 1, but your result average is having 4. I think. Let's see. Yes. 4
It
significant.
doesn't take into consideration.
it doesn't work out the.
Just to be controlled by someone. Yeah.
So there is a power function. This one you use it for raising a number to a particular power. For example, if you want to raise 2 to the power 3, so you give it the base and the matrixer and the exponent. So in this particular case, the matrixer is the 2, the exponent is 3. So 2 to the power 3. When you do that, that's going to give you 8. You can also here, for example, raise 25 to the power half. So it's the power 25 to the power half. Basically, we know that this particular mathematical operation corresponds to a square root operation, and you get
Why does it have to do?
our internet.
Oh, okay.
It needs to.
Google space. Is it from Google?
Oh.
They run this from Google somewhere. Access what will be given to.
So finish
You
it.
called it the code. Why did you call it?
Hmm?
This way of putting the work on Google.
Mm.
You called it CO.
Collaboratory. Google collaboratory. Let's see how much internet I have. Okay, I think I should probably.
We still have 40 minutes.
Change the internet.
Minutes for
I'm trying to change
some portion
my internet.
questions.
My internet. Okay. Just a minute. So we are using this platform so that you can work with other people. If you share this particular file with your friends, then you can all work on the same project from different places. Did you connect it? Okay. So there. Alright, so there it is. Then if you can also raise something to a fraction, and you're going to get that. Then here we have got the function around. So with the function around, basically you can specify the number of decimal places you want. So here I create a variable pi, and I print out pi. Then if I want to display pi to 0 decimal places, I give it the name of the variable. Then next argument will be the number of decimal places I want in this particular case. So round pi to 0 decimal places, and I get that 3 point that 0. Then if I want, then I'll get that. Then if I want to round it off to 3 decimal places, then I'll get that. This one is another one, the range
so
function.
maybe while you are just still there, is there a function which rounds to even? I don't know how best I can say this.
So to whole number.
Yes, but to even, because for example, maybe try a number 1.6500.
Okay.
Just the variable create.
No, I can just create it. Say round 1.6500.
0.00. Round to 1 decimal place.
To 1 decimal place. So I get 1.6.
Okay, yeah. So it's clever. You see, the 5 doesn't upgrade to 7.
Basically,
I hope you see.
Yeah.
You understand what I'm trying to say.
5 doesn't break to 7.
Yeah,
It just gives you up to
yeah, but
that many decimal places.
Oh, yeah.
It's not upgrading.
But put on the last zero, put a 1. It should be able to
Where?
round to 7. The last zero, put a 1. Put
Here.
a 1 on the last, yeah. Round.
Oh.
Yes. So it
How will-
rounds to even.
Because of the significant figures.
Yes.
Ah. Okay. So that's something I wasn't aware of.
That's a good one.
Because the zeros after 5 are not significant.
Yes.
But when you put 1 there, 1 is a significant figure.
Okay. All right. Okay. All right. That's something I just learned also. All right. Then there is a range function. Now, the range function, you use it for creating a list quickly. A very simple list. For example, in this particular case, I want to create a list which runs from 0 to 59. But I don't want to create this manually. So I use a range function here. So I say that bit there. Then I check out what kind of what thing I've created. It's a range. If I try to print the range, you see this is what you get. But you can change this range into a list. So you give it to the list function. Remember, we've met the list function. So I give the minutes to the list function, then I store it back into minutes. Now when I make a printout of minutes, this is what I get. 0 all the way up to 59 there. So basically, this is a quick way of you creating your list of values. If you need values from 0 to 59, you can do that. You can also, for example, you can state where you want to start from and also where you want to end but excluding. So I want to start a list which starts from 1 up to but excluding 13. Basically, this is months. So I want a list of months from 1 to 12. I can do it like that. Internet is
I need stable internet.
yeah.
Something we must consider. Maybe the department can be helping us with an independent one from UNGA for the seminars. Because imagine, for some people online, it would be sad. It can break in transmission. Well, that's what is happening to students.
This has been my internet from the phone. So let's do this. Yo. Oh, it has been gone.
He's using from his phone. Oh, now it's back on.
No, yeah, let me go back on my stuff. That's where the thing is. Okay, then I do a printout there. Then I convert this range by giving it to list. Okay, then I print out there. So I get my list from 1 up to 12 like this. So you can give range 1 argument, you can give it 2 arguments. If you give it 2 arguments, that's what you get. Or you can decide to create a list in steps. So you have to give it a start, an end, but excluding, and the step size. For example, I want a list from 0 up to 99, but in steps of 2. So I'll do this. So it will start from 0 up to this bit, but in steps of 2. Or I can probably even say, let me start from 1 up to 101, but I'm going to do it in steps of 2. If I do that, but again that defeats the purpose of the even bit there, because 1 is not even. 0. Yeah. That, then I print out this, then it's a range like that, so I start from that up to there, then I give it to the list, then I make a printout of this. So you see I get a list in steps of 0, 2, 4, 6 like that, all the way up to...
So,
yes.
Instead of putting this there, can you put a tuple?
You can put anything. You can put a list or a tuple. Doesn't really matter. Okay. Okay. Another one is this function called evaluate, short for eval, short for evaluate. So here I set out the variable x to 2. Then I want to evaluate this particular quadratic here. So the way I do this is I co-evaluate, then I give it a string. You can see the quotation marks, which contains this particular, the equivalent of this particular mathematical expression. That is basically x to the power 2 plus 3 times 4 plus that. Then, since I've already set x to 2, this is going to evaluate to, it's going to 14. So basically that's how that particular one works. Here,
just of interest, so here for power you are using 2, what do they call them, asterisks.
Yes, for explanation.
The power.
Yes, you can also do that.
Okay.
Yeah. Then, if you've got a list, for this is for enumerating, and you have a list like weekdays, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, then you want to match these weekdays with numbers. Okay? So in that particular case, you would have that. Then you print out your weekdays. Then you give these weekdays to a function called enumerate. Then it's going to create an enumerate object. If you print out days, it will look like it doesn't. It will just give you just created an enumerate object at a particular address. But if you get this object you have created, then you give it to the list function. That's why the list is very important. Even if you create something which cannot be seen, but if you give it a list function, the list function will try to convert that into something which you can see, like that. Then if you do a printout here, you see now your Sunday is being matched to 0, your Monday is being matched to 1, like that. So basically you end up with this kind of arrangement here. Last but not least, I think there is a sorted. Of course, you've got your weekdays. You can sort it out alphabetically, give it to the sorted function. This is what you get. So Friday, Monday, like that. But itself, basically what you get is a copy. The actual stuff itself has not been changed. Then the last one among the functions we're going to look at is something called, this is short for execute. Now, this function does something quite clever. You can have your codes. So basically, your Python codes, you can string them up and put them, this is the first code, line of code, then the second one, here, then I print out something. So these lines of code, you can actually enclose all these lines of code in quotation marks. So basically, you have got your codes, then you turn them into a string. Yes. Yeah. You turn them into a string like that. So when you turn them into a string like this, then you can get this particular string. You save it in a variable like this. Code. Then you give this particular variable which contains this string with these Python codes to this particular function called execute. So when you give that to that, then it will start to run these particular commands. So in this particular case, enter your first name, which is the first instruction which is being executed there. So I say fine, I'll enter my first name. That's gift. I press enter. Then enter your second name. I'll do that. Then it runs the rest of the stuff which is like that. So basically that's how you use the execute function. So basically those are some of the functions we wanted to look at. The next bit is I don't know if you're going to have enough time, but basically I can get started. These are called user-defined functions. You can actually create functions yourselves. And how do you do that? Well, for you to create a function, what you need to do is first, you need to start with this particular keyword, define. Then followed by the name of the function you're going to create. Then after that, there will be a pair of parentheses. These parentheses are where you are going to state what kind of information that particular function needs. Then after that, you end with a semicolon. Then after you end with a semicolon, then comes this bit here. This is what is called the function body. So here, this doc screen, this is basically your explanation of what the function does. So when you call help on this particular function, the help function is just going to read this particular text. Then here, you have got the task statements, what that particular function is going to be doing. Then if the function is carrying out a calculation, when you find the answer to the calculation, then you can give us back the calculation. So basically, a function works like you say, oh, I want these things done. Okay, fine. Then it goes to the back room, does whatever it does. When it finishes, it comes back, gives you back the answer. Basically, that's how functions work. The information you pass to your functions, as you have seen, those are what are called. When you're creating a function, you can state what kind of information the function will need. So at creation, that information which is going to be needed, that's what's called a parameter. When you're calling a function, the information you give it the function when you're running it, that's what's called an argument. So basically, in our case here, we are going to create a function called subtract. So you start out with def, define, then the name of the function, which is subtract, then what information does it need? It needs two numbers, and I've given them names. So first number and second number here. Then after that, I end with a semicolon. So basically, this here, that first line is what's called a function definition, where you state the name of the function and what kind of information the function is going to do. Next comes this particular string here, which is in triple quotes. As you can see, there are 3 quotations, single quotation side, and 3 matching that side here. This is what is called a doc screen. What does it do? It gives you a description of what the function does. Return the difference between 2 numbers. Then next, I carry out the task which the function is supposed to do, which is the calculation in this particular case. First number minus second number, then the difference, the result, I store it in a variable called difference. So basically, this is a task which the function is doing. Then after that, now I want to give you back what the difference of the calculation is, and that's what I do with this particular statement here, return difference. So when I run this, Python accepts. When I check what I've created with subtract, I give the type function the name of subtract. It tells me subtract is a function. Then if I try to ask for help on what subtract does, then it tells me, okay, fine, this is the name of the function subtract. This is the information subtract will need. It will need a first number, it will need a second number, and this is the task which subtraction does. So it gives you that description. As you can see, the actual operation implementation of how the subtraction is being done is not displayed. Okay? So now we can call the function subtract. Now, if you're going to call a function, you need to have an idea of what information the function needs. In our case, our subtract function needs 2 pieces of information. It needs a first number, it needs a second number. If I try to call subtract without any of those informations, without first number and second number, then Python is going to tell me that there's an error. This function doesn't work like this. Some information is missing, subtract, missing 2 required positional arguments, first number and second number. So if I want this function to work, I need to provide those pieces of information. Okay, now, since our function needs information to work, we'll have to provide that information. The information you provide, once you have created the function for it to work, those are what are called arguments. And there are 2 ways in which you can give this particular information. There's what is referred to as positional arguments, and there's something called keyword arguments, and we're going to look at that quite quickly. So if I say subtract 10, this is the first argument, then 6.5, then I run this, I get 3.5 as the difference. Basically, what this function does is it matches the first argument, 10, to first number, and it matches the second argument, 6.5, to the second parameter, which is what you have up here when you when you ask for help or subtract here. So the 10 is matched with this first parameter, then the 6.5 is matched with the second parameter. This is what is referred to as positional arguments. Basically, the things are matched the way you have given them, like that. If Okay, so if I do subtract with 6.5 and 10, you can see the 6.5 is now matched with first number, then the 10 is now matched with second number, so I get minus 3.5. If I don't want to have that, then I can specify where the numbers are supposed to be. I can say then the value 10 should be stored in first number, the value 6.5 should be stored in second number. If I do that, then this is what I get. These are what are called keyword arguments, when you specifically state explicitly where a particular value is, in which parameter a particular value is supposed to be matched with, like this. If I do the same thing for second number, I say 6.5 and first number is stored like that, then you can see that now it does not matter which one comes first, because the matching is being done explicitly. With positional arguments, you are leaving that to the computer to match the parameters, but with keyword arguments, you do it explicitly. Okay, then you can store whatever result comes out from a function. The result you get after a function has done its stuff, that is what is called the return value. That return value, you can store it in a variable, in this particular case, answer, like that. Then you can print out answer, like that. Same here. And then, if you have a function which stores, which you want a function to give you back multiple values, then the values you are getting back from the function, you can return them as a tuple. For example, remember we're with the power function, but we have created another power function here which works out the first power, then it switches things. So basically in this particular case, n to the power second number, then second number to the power first number, and it gives out what these powers are. So here returns the power of the first number raised to the second power and vice versa. So here I calculate the two powers. The first power is first number to the second power, and work out first power, then second number to first power, this will be my second power. Then I want to give out these two powers, so you can return those particular values using a tuple like this. So this allows you to return your things like that. Okay, then you check the type, what is raised to power, then you can ask for help. Then if you run this particular one, you see what you get. So you get a tuple. So this is the first power, and that is the second power. That is basically 2 to the power 5, 32, and 5 to the power 2, that's the 25 you get there. So if you want to return multiple values from a function, that's basically how it's done. If you want to store this in actual variables, then you have to do this here. So the first place, where is it supposed to go? You have to create a variable for that. Where is it supposed to go? You have to create a variable for that. Then you can print them out like that. Let me just do this bit here. This other bit is a completely new topic for lambdas, but I don't know how much time we have.
Time is actually over.
What time is it?
It's already 10:51, so some people have to go for lectures probably.
Okay, so let me do this one. Sometimes, remember how we did the average calculation? But you want to create a function which will work out the average for any number of numbers you provided. But the issue is you don't know ahead of time how many numbers a person is supposed to provide for you to work out the average. So the way you do that is you define your average function, then you put a star in front of numbers. So this star in front of numbers, this is going to create a tuple. So when you provide numbers, let's say 3 numbers, those 3 numbers, when you provide them, like 10, 15, and whatever it is, those numbers will quickly be changed into a tuple by that star operation. Then you can use that tuple to carry out this particular calculation we did. Remember when you're working out the average thing there? Yeah. And I have intentionally decided to print out what the tuple is going to look like once this operation is done there, so that you can see what this bit actually does. So here, let me just come to here, so end of time. So average 10 and 5. So for average 10 and 5, you see the 10 and 5 are converted into a tuple. Then based on this tuple, the average gets worked out. If you have these particular values here, average 10, 5, 15, 7, and that, then these numbers are quickly converted into a tuple like this, then the average is worked out. So basically that's what the star does. It gets your numbers you have put there, then it changes them into a container, then using that container you can work out the sum, then you can do your things, your magic stuff like that. So I think I will stop here. If there will be another opportunity to do this, then I can show how to work out the lambda bit, which is small but
All right, thank you,
Yeah.
Mr. Sean. Maybe just one question, if there is any question.
Yes, I have a comment.
yes.
Sometimes I think we may need to teach Python from first year. You know the
Professor,
reason
I'm
why?
being ambitious.
No, why I'm ambitious is you go to the exam room and the student tells you, my calculator is giving me wrong numbers. It's not giving me the correct value. And you see some of these functions are the functions inbuilt in the calculator. They are the same.
Yes.
There's nothing different. For example, averaging, summing and averaging. That is a common function in most of these scientific calculators.
Yeah, maybe just a comment.
That's yes.
At MIT in USA, they teach Java programming at first year to everyone. It doesn't matter whether you are in engineering, you are in humanities. If you register for the course, Java course 100, you can take it. And I think Mr. Sichone will remember that I proposed that we work with our colleagues in computer science to have a Python course for first year that maybe cannot be examinable, but we just want to give these tools to our students. So we may be working on this, but we haven't seen any serious response from our colleagues, and hence we decided to start here. Yeah, those who are willing to join us.
Mr. Zuni, you see why I'm saying this. If you press that function x to the power 2 on your calculator, you are doing these things.
Yes.
Back in the 70s, when I was in graduate school, these scientific calculators were not that advanced. So there was a Texas Instruments programmable calculator.
Yes.
So I used to program that and then work out my assignments. Even for the exam, there was a time to give us this question. Some you say, try to this hereafter, and there is some kind of
Small one-line function. So the way you make these lambda functions is you start out with this keyword called lambda, then what kind of information the function will need, then followed by the expression. Now, how does that look like? For example, if you look at this particular equation here, which you have here, f of xy, then 3x squared plus 4xy minus 5. So here, this is the expression. That is what is going to come here. That's what you're going to type there. Then the x and the y, these are the pieces of information the function needs. That's what you're going to put here as the arguments. So you say x, comma y, so you lambda x, comma y, then that. So you would have created that. Then this expression we have done here, you can save this expression in a variable. Then you can move on from there. So in this particular case, if you look at what I've done here, I start out with lambda, which is that. Then this particular function needs an x and a y, which is what I'm saying here, an x and a y, then followed by this particular expression which you have here, 3 times x to the power 2 plus 4 xy minus 5. All of this I save in a variable f, like that. So I have created my own one-line function like that. These lambda functions are very, very good for mathematical expressions. You can, whatever mathematical expressions, one line like that. Then if I ask what kind of stuff I've created, Python tells it's a function. Then how do I use that? Of course, we know we have looked at positional arguments and keyword arguments. If I say f 3, 5. So basically it means that the 3 will be matched with the x, the 5 will be matched with the y. If I do that, I get my 82. If I switch them, F53, if I do that, I get my 130. If I use keyword arguments, in this particular case, say f x to 3, then y to 5, then I get my 82. If I switch them like that, I still get my 82. Here it doesn't matter because I'm specifically saying 5 should go into y and x should go into 3. And if I do that bit there, I do that. Of course, the results of these particular calculations here, I can save them in a variable. For example, here, this particular one here, if I say x into 3 and y into 5, so it runs out, it gives me the result. Then that result I can store in answer, then I can print out that bit there. So basically, that's the end there. That marks the end. So basically, those are Lambda functions. Tiny, tiny one-line mathematical functions, but powerful and very useful. They are small, but they punch big. Yeah. So that's the end.
Okay, thank you very much. So as Mr. Sichone has put it,